Hello everyone, hope all of you are doing great. And in today's video, we're going to discuss Unit 1, Paper 1 in the classified book. The first question here says, Mia and Lily are trying to find the nearest whole number to square root of 120. So how can I do this? Mia is saying it is 10 and Lily is saying it is 11. This is just another way of saying it to you estimate the value of square root of 120 to the nearest integer, or write square root of 120 to the nearest integer. Okay, so we agreed to find the value of a third to the nearest integer. I need to find the perfect root before it. So what I'm going to write over here is that the perfect root before 120. You are supposed to know all the perfect roots until 12 times 12, which is 144. This is a square number, which is the root of 144. But the perfect root before it is square root of 100, which is 10. And I got also square root of, what is the perfect root after it? You're going to have 121, which is 11. All right, in the middle, I got the square root of 120. It is greater than square root of 100 and less than square root of 121, but it is closer to 11. So I must write here square root of 120 is closer to square root of 121, which is 11. That's it. So you're supposed to tick Lily. All right, next question here says, just a second. Write down all the primes between 60 and 70. We agree that a prime number is a number that has only two factors, 1 and itself. So I got there exactly 61 because it doesn't factor, it has only 1 times 61. There is nothing else that you can do about this. And you've got also what? What are you going to find over there? 67. That's it. You're not going to find any other numbers between 60 and 70 that are prime, only 61 and 67. All right, don't think about 63 because it's divisible by 3 actually. So it's not going to work. Don't think about 69 because it's also divisible by 3. It's not going to work. It's going to give you exactly 23. So it's not going to work. All right, let's continue. Each of these numbers is written as a product of prime factors. Here you go. Use this information to write 539 as a fraction in its simplest form. So what I'm going to do over here is replace this 539 with 11 times 7 squared. 539 is actually 11 times 7 squared. That's what the question says. So I'm going to say 11 times 7, but instead of writing 7 squared, I'm going to write times 7 again. And here it's 847 is 7 times 11, but times 11 again. That's what the question says. All right, so in order to answer this, and in order to simplify it, we just divide or we cancel from the numerator with the denominator if there are common factors. So here I got 11, bye-bye with this 11. The 7, bye-bye with the 7. So what I've got over here is 7 over 11. All right, the next question says 55 over 539 in the simplest form. Good. Here I need to factorize 55 by myself. Prime factorize it, you're going to find out that it is 5 times 11. But over here I got 539, which is 11 times 7 times 7. From the numerator and the denominator, I got a common factor. Bye. So it is 5 over 7 to the power of 2, which is 5 over 49. The next question here says to you, 2 plus 8 multiplied by 40 minus 5. We agreed that this here means multiplied. If there is nothing, if I write like this means multiplication. So what are we supposed to do here? I'm supposed to start with the brackets order of operations. Yes, I'm supposed to write with the brackets first. Start with the brackets. So here it's going to be what I'm going to have here. 2 plus 8 multiplied by, finish the brackets, you're going to find 35. After that, can I start adding 2 plus 8? No way. Come on. We agreed before that you got first to the brackets. 1 second. First, we've got the brackets. After that, you got any exponents like x to the power of 3, for example, or any number to the power of any integer. And we've got after that the multiplication or division in order from left to right. And at the end, we've got addition or subtraction in order from left to right. 8 multiplied by 35, you're going to find that it is 280. Add to it the 2 is going to be 282. Let's continue. Find the largest positive number that can be made when two numbers from the list are multiplied together. So you're going to find that the largest positive number you can get is not the largest two positive multiplied. No, it is actually here. Also, I've got -5 multiplied by -7 is going to give us 35. And subtracted from each other, you're going to find that you have here 6 minus -7. If you subtract 6 and -7, 6 minus -7 this way is going to give you the largest possible answer, which is 13. Oh, how did you get the 13, mister? We agreed negative is going to turn into plus. So 13 as agreed. Here is 13. All right. Work out. Here, as we agreed, we need to start with the brackets. So let's do it. Here, 4 squared. So I'm going to write the 5 as it is. Multiplied by 4 squared is going to become 16. 16 plus 2. So 16 plus 2 is going to be 18 minus 12. So 5 multiplied by 6, which is just simply 30. The sum of 3 consecutive whole numbers is 54. Work out the 3 numbers. This just requires a little bit high sense of how we use the numbers or sense of numbers. So do not think about numbers starting like 7 plus 8. Do not start with that 7 plus 8 plus 9. Oh, definitely these 3 are not going to give you 54. And we need to remember that consecutive means they come right away after each other, like 7, 8, 9, like 1, 2, 3, like 10, 11, 12. These are consecutive numbers. They are called consecutive numbers because they come right after each other. Good. So do not start with small numbers like these. I already know a mister, so that, for example, 15 plus 15 plus 15. Oh, mister, they want the 3 definitely different consecutive numbers. Yes, I know, but what I mean here is that I know that 3 15s will give me 45. I haven't even reached 54, so I cannot start with numbers less than 15. You can't. You can't start with numbers that are less than 15. Okay, so here it is all about how good you can just work with numbers in addition and in subtraction. So here I know that it's definitely more than 15. All right, so you're gonna find that it's 17, 18, and 19. Let's try this. I think if I remember it right, it's gonna be here 17, 17, and 7 is going to be exactly 24, 24, and 30 exactly. So 17, 18, and 19. These are the 3 consecutive numbers that if you add them, they will give you 54. Let me erase this, not to confuse you. All right, let's continue. Estimate cubic root of 120 to the nearest whole number. Well, to do this semester, I need to find the perfect root before it, which is what? What is the perfect root before this? You're going to find that I have cubic root of 64, which is actually equal to 4. And right after it, I have the cubic root of 125, which is equal to 5. Which one is it closer to? Yes, it's closer to 5. That's the nearest whole number. 9, work out the value of this. Well, 5 squared, I know that it's 25, plus square root of 121 is 11, so it is going to become 36. Simplify. Oh, we agreed when we multiply numbers with the same bases, the bases are the same, you add the indices, you add the powers, so it is x to the power of 9. Here, in order to find this 7.4 plus what is 3.1? Oh, mister, how come, how on earth that I add to 7.4, it gets smaller? Oh, yes, it is possible. How, yeah, mister, how come addition makes numbers bigger? Oh, yeah, unless you're adding a negative number. So definitely I'm adding here a negative number. So 7.4 plus what? Plus negative what is going to give me 3.1, as if you're minusing. So it is as if you are minusing. So you're going to find that if you minus here 0.3, and you've got over here 4.3. Negative 4.3 is going to give you exactly 3.1. So how can I do this? We agreed if I have negative negative, we just said it a few minutes before, earlier, you're going to say negative 9.4 plus 5.7, which is going to give you exactly 15.1. All right? For those who do not know how to do this mentally, if you don't know how to do it mentally, no problem at all. Just line up the decimal points. That's in addition and subtraction. Here is 9.4. Here is 5.7. Add them up is going to give you 11. Correct the 1 is going to be 15.1. The most important thing is that you line up the decimal points in addition and subtraction of decimals. Use numbers from the list to complete the sentences. You may use a number more than once. The square numbers are what and what. So here I got the square numbers. 9 is a square number, and we've got also 36 is a square number. All right, the factors of 18 are, yes, I have 2 is a factor of 18. I have 9 is a factor of 18. I don't have anything else as a factor of 18. The multiples of 4 are, well, 4, the multiples means that like the times tables of 4, like 4, 8, 12, 16, and so on. So the multiples of 4 are, I got here 20 is the first multiple of 4 on the list, and I got also 36 is a multiple of 4. Good. Next question. 10 times 10 is the same as 10 squared. Yes. 10,000 is the same as 10 to the power of, I have 4 zeros, so 10 to the power of 4. 1 million is the same as, Mr. It has 6 zeros, so 10 to the power of 6. 1,000 divided by 0.01. Oh, how can I do this, Mr.? Well, you took this actually last year, and you're going to take it also again this year in Unit 3. If you are dividing by, how can I read this and don't say 0.01? It is called hundredth. It's called hundredth. So in order to do this, we just say 1,000 times 100. Isn't this 1 in the hundredth place? The place value. I got here the units before the decimal point. After it, the first digit after the decimal point is called tenth. The second digit after the decimal point is called hundredth. So this is 100th. If you're dividing by 100th, then it's the same as multiplying by 100. And if you were multiplying by 100th, then it's the same as dividing by 100. Okay, so just to switch the sign, and the hundredth, make it 100. So which is actually how many zeros? It's going to be 100,000, 5 zeros, which is 10 to the power of 5. Question 14. Here, you're going to just need to line up the decimal points. First, we know here that 14 plus negative is going to be 14 minus 5.5. 14 minus 5.5, what is it going to be equal to? Well, use the what? You can use mental math. Just mentally, I know, Mr. If I take away from the 14, 5, it's going to become 9. 14 minus 5, أصلا Mr. is equal to 9. But take away more, a half more. So it's 8.5, Mr. But Mr. I don't know how to do it mentally, please. Okay, no problem at all. Line up the decimal points as we agreed before. In addition, subtraction of decimals, it is 14.0 minus 5.5. 0 minus 5, I can't borrow. This becomes 3. So it's 10 minus 5 is 5. 13 minus 5 is going to become 8. So it's 8.5. Here, in multiplication, you are supposed to ignore the decimal point first, and then we put it at the end. So negative 6 times negative 15. What is negative 6 times negative 15? Definitely, Mr. is going to be positive. Negative times negative is positive. Good. What is 6 times 15? All right, you can do it mentally. Great. If you know that it is going to be 90, awesome. If I don't know, Mr. how to do it mentally, 6 times 5 is 30. Carry up the 3. 6 times 1 is 6, and 3 is 90. So Mr. is positive 90. If you don't write the positive, it's not going to be a problem at all. But if you leave it this way, it's going to be wrong. Why, Mr.? Because it's not 15 times 6. It is 1.5. So there is a decimal point here, one place. So there is a decimal point here, one place. So it's 9.0, which is just exactly the same as, yes, 9. Just 9. Okay, so this is 1.5, which is 9.0. All right, let's continue. This question, it says to you that if you add all the rows, they are equal to 15. This row, if you add them, equal to 15. This row, add it equal to 15. If you add any columns, any of the 3 columns, they are equal to 15. Even the diagonals are equal to 15, the diagonals. Good. So what are we supposed to do to complete this? All right, let's look at this. 13 plus 5, 18. 18 minus 3, okay, that's going to give me a 15. All right, so we're going to play the same game. But for example, can I try to find this square in the beginning? No, I can't. Why, mister? Because I have too many missing numbers. I need a row or a column or a diagonal where only one square is missing so that I can find it. So let's start, for example, with this one here. Yeah, this column, I got 2 numbers known, only one is missing. So these 3 must add up to 15. 12 plus 5, 17. 17 plus what is 15? Negative 2. Okay, now I found another number here. I can find this one. 13 minus 2 is... Oh, mister, you said we add. Yes, but if you add 13 plus negative 2, it's the same as 13 minus 2. So 13 minus 2 is 11. 11 plus what is going to give you 15? 4. Good. Here, 4 plus negative 3, which means 4 minus 3 is 1. I need 14 to reach the 15. Okay, here, negative 3 plus 12 is positive 9. Positive 9 plus what is 15? 6. 6 and 13 is 19. 19 plus what is 15? 19 plus negative 4 is going to give you the 15 that you want. Okay, here, they're saying to complete this statement using a consecutive whole numbers. This is exactly as if they're saying to you, square root of 40 is between what and what? Square root of 40. What is the perfect root before it? The perfect root before square root of 40 is going to be square root of 36, right? And what is the square root after it? The perfect root after it is root of 49. So it is between 6 and 7. Because square root of 36 is 6, square root of 49 is 7. And don't forget, don't write square root of 36, square root of 49, because they've said they want the consecutive whole numbers. So it's 6 and 7 is the answer. Mia has 2 ribbons. One is 60 centimeters long and the other is 45 centimeters long. Mia cuts both ribbons into pieces. All the pieces have the same length. Find the greatest possible length of each piece of ribbon. All right, in order to do this, you need to find the greatest. If they give you like 2 numbers, like 60 and 45, and both of them are kind of connected with each other, like what is happening here in this example, and asking for the greatest possible length between both of them, that means that they wanted that greatest common factor or highest common factor. If you can find the highest common factor, then thank you, you will find the answer. How can I find the highest common factor? We didn't revise this part. You took it last year and the year before it and the year before it. You took it started from year 5 and year 6 and year 7. Let's revise it right now. This unit in the classified, it has the concepts that depend also on previous knowledge from year 5, year 6, and year 7. Let's revise it right now. How can we do the highest common factor of 60 and of 45? If you took the factor 3, no problem. 60, let's factorize it. It is 6 times 10. And here I got 2 times 3. But here I got 2 times 5. I cannot continue because they are primes. So this is a prime number, prime number, prime number, prime number. So 60 is actually what? 2 times 2 times 3 times 5, right? While 45, let's do it. You're going to find that it is 9 multiplied by 5. And 5 is a prime number, so 9 is 3 multiplied by 3, which is actually 3 times 3 times 5. For the highest common factor, I take the common only. I take that common only once. So the 2, is it common here and there? Nope, so don't take it. 2, is it common here and there? Nope, so don't take it. 3, is it common here and there? Yep, so take it once. By, and write it only once. 5, is it common here and there? Yes, by, and write it only once. So what is it going to be? It is going to be 15. Let me just not write highest common factor. Now I need to write over here 15 centimeters. This is the answer, finding the highest common factor between 60 and 45. Write these numbers in order of size. This is standard form. This is 1.2. We took this here. All right, how can we do it? Here, these are not all actually standard form. They're not all standard form. So let's answer them. These are not standard form, so let's just answer them. Here, 0.48, what is it going to be? Yes, it is going to be 4800. Remember, these are not standard form. That's not the same like what we took in 1.2. Actually, we took it in 1.2, but answer it in full. Remember the questions that say to you, answer in full. You must write the answer in full. 4,800. Here, multiplying by negative, we took this. It means as if you're dividing by 100. And instead of saying multiplying by 100, it's dividing by 100, which is 0.16. Here, dividing by negative, it's as if you're multiplying by positive. So as if you're saying 7 times 1,000, which is 7,000. Dividing by positive, like this is normal emitter. Move the decimal point that is at the end, 4 digits to the left. So 1, 2, 3, 4 becomes 17.5. So now we can order. Smallest is which one? The smallest is this, 16 times 10 to the power of negative 2. Here, what's after that? After that, we got 175,000 multiplied by, divided by 10 to the power of 4. And after it, we've got 0.48. 0.48 multiplied by 10 to the power of 4. And here, the last one that you have is the largest one, which is 7 divided by 10 to the power of negative 3. Next question. Work out the value. Square root of 49, we know that it's 7. Plus 6 squared is 36. So it's going to become, what? 43. Next. It says to you, Angelique has 12 sweets. Mia has 3 more sweets than Angelique. So let's write here, Angelique 12. While Mia, 3 more than Angelique, which is 15. 12 plus 3, which is 15. Let me just, for those who might get confused, it's 12 plus 3 because they said 3 more than Angelique, which is 15. All right, and they said Oliver has 5 less sweets than Mia. So 15 minus 5, which is 10. Find how many sweets they have all together. So I have 12 plus 15 plus 10, which is, you're going to find here, this is 25, 35, 37. This is the answer. The 5-digit number is a multiple of 9. All right, so multiples of 9. What are we supposed to do to find the multiples of 9? How can I know that it is a multiple of 9? Add all the digits up. Add all the digits up, and they must give you a sum that is in table 9. This is from the divisibility rules. From the divisibility rules. Okay? So here, I need, what is 7 plus 6? 7 plus 6. 13, mister. 13 plus 5, 18. 18 plus 3, 21, mister. All right, good. So if you add the 4 digits up that we have, they give you 21. What is another digit that you add and gives you something in table 9? They give you something in table 9. 21 plus what? Oh, mister, in table 9 we have 27. Perfect. I have 27 in table 9. So if I add here what? If you add here, mister, a 6, this whole thing will be a multiple of 9. So if I add 3 and 6, 9 plus 5, 14. 14 plus 6 is 20. 20 plus 7 is 27. So definitely now this new number is a multiple of 9 because 27, when I added them all up, they gave me 27. 27 is in table 9. Thank you so much. So now it works. Work out the missing digit. It is a 6. All right. 7 to the power of 0 times 7 to the power of 2. We agreed 7 to the power of 0 is anything in the world to the power of 0 is 1. So as if you're saying 1 times 7 to the power of 2, which is 7 to the power of 2. Or we agreed that if the bases are the same, we add the indices. So it is a Mr. 7 to the power of 0 plus 2, which is just 7 to the power of 2 برضه. So this is here. 7 to the power of 0 times 7 to the power of 0. Oh, mister, 0 plus 0 is 0. Or 1 times actually 1, because we said this is 1, this is 1. It's just going to be 1, mister. 7 to the power of 6 divided by 7 to the power of 2. We agreed in the indices. You subtracted that. In the division, we subtract the indices if it is division. So 7 to the power of 4. This one, add the indices. 7 to the power of 2 times 7 to the power of 1. This is not 0, for God's sake, please. This is 7 to the power of 1. So it's 7 to the power of 3. Next, how can I calculate this? 4.5 squared times 2 squared. Mister, 2 squared is 4. Excellent. 4.5 squared, how can I do it? I don't know how to do it. Well, just do 4.5 multiplied by 4.5. And paper 1, we don't use the calculator. So here it is 45 times 45. Mr. Ahmed said that in multiplication, ignore the decimal point. So 45 times 45. 5 times 5 is 25. 5 carry over the 2. 5 times 4 is 20, and 2 is 22. Put here a 0. And sorry for my terrible handwriting. And here, 4 times 45 again is going to give you 5, 2, 2 as well. So, oh, sorry. All right, here we agreed 225. 5 times 5 is 25. 5 carry over the 2. 5 times 4 is 20, and 2 is 22. Put a 0. Here, 4 times 5 is 20. 0 carry up the 2. 4 times 4 is 16. 16 and 2 is 18. Then you add them up. Here is going to be 5, 2, 10. Carry up the 1 is going to give you 2. But I have them as 2 decimal places in the question. I have 1, 2 digits after the point. So I want 1, 2 digits after the point. It is 20.25. Must be multiplied by 4. Okay, good. If you know how to do this mentally, it is 20 times 4, which is 80. So this gives me 80 from 20 times 4. Quarter times 4 gives me 1. So it is going to be 81. But, mister, I don't know how to do it mentally. No problem at all. Just to do 20.25 multiplied by 4, just exactly the same way that we did over here. You're going to find that it's going to give you at the end 8,000 exactly. It's going to give you 8,100. But I have 2 digits after the decimal point, so it's going to give you 81.00, which is the same as 81. Just to do the multiplication normally. All right. Let's continue. This one here. This question, I'm going to need you. This question, I would need you to skip it for now until we go to Unit 2. So you can just skip this question for now. Complete this. Just normal multiplication. 4 by 6 is 24. 4 by 9 is 36. 7 times 6 is 42. 7 times 8 is 56. Times 9 is 63. Find the highest common factor of this. We agreed. Common factor? No problem at all. We're going to do the factor tree. 39 is going to be 3 by 13. Thank you. Prime, prime. But here, so it's 3 times 13. While here, 52 is actually what? Let's try to find. It's actually 2 times 26. Here, circle the 2. The 26 is going to become what? 2 times 13. Circle, circle. The 3 of them are prime right now. So this is going to be what? 2 times 2 times 13. All right, for the highest common factor, what are we supposed to do? Ask yourself, we take only the common ones. 3, is it common there? No, so we're not going to take it. 13, is it common there? Yes. So by, write it only once. Anything else is common? No, mister. So it's just 13. The highest common factor is just 13. Draw a ring around the number that is nearest in value to the square root of 74. Oh, mister, square root of 74. I wanted the number that is closest to it, the nearest to it. No problem. We learned this. We practiced it so many times. I get the root, the perfect root before it, which is what? Root of 64, which is actually equal to 8. And the perfect root after it is actually root of 81, which is a 9. It is a mixture between 8 and 9. But which one is it closer to? You're going to find that it is closer to square root of 81, which is 9. But one second. Did they say here, what we've done here is perfectly correct for a different question? What do you mean, mister? What I mean over here is that they said draw a ring around the number. Did they say that is nearest in value to the square root of 74? Did they say the whole number? No, they didn't say the whole number, which means what? Which means that it could be a decimal. It could be a decimal. All right, but how can I know, mister, the decimal? I need to know first, is this closer? So now I got, let's say, we agreed it's very close to 9, right? Let's say, is it closer to kind of like 8.5, this one, or to 9? 9, it would be like square root of 80, square root of 79, square root of 78. It is a little bit, mister, far from 9. It is closer to 8.5, which is almost, it is halfway between root of 64 and root of 81. If you noticed, the difference between this and 81 is 7, and the difference between this and 64, it is around 10. So it is a little bit more than the half. It is closer to 8.6 actually. Okay, so it is not 9. We're going to even discuss this question a little bit more in the class. Question 26. But it is, yes, closer to 9 if they said to the whole number, but no, mister, it is very close to the halfway between root of 64 and root of 81, which is very close to 8.5, so 8.6. This one here, all right. They're saying to you, mister, we learned that in multiplication, we add the powers. In division, we subtract the powers. So as if I'm saying to you, 7 plus what? Minus 4 gives you 8. Okay, so as if you're saying 7 plus what? Minus 4 will give you 8. Well, mister, let's do 7 minus 4. 7 minus 4 is 3, right? So as if you're saying 3 plus what will give you 8? It's 5, mister. Okay, now let's try it. Look at this. 7 plus 5 is 12. 12 minus 4 is 8. Next, work out this. 23 minus 3 times 3, all to the power of 2. We agreed order of operations. You must start with the brackets, but inside the brackets, mister, I have multiplication and I have subtraction. So what is going to happen here, mister? You need to start with the multiplication. 3 times 3 is 9. And then I do 23 minus 9, and all is squared. So 23 minus 9 is going to be what? 14 squared. Then you do 14 times 14. Here is going to become 16. Correct the 1. 5, add 0, 4, 1, becomes 6, 9, 1. So it's 196 semester. Next. I got here, they're saying to equal to 7 to the power of 6, not equal to 7 to the power of 6. This one here, equal to 7 to the power of 6? Well, no, mister. 7 to the power of 6 is B. 7 to the power of 6 is C, because I'm going to subtract the indices. 6 minus 0, 6. 7 to the power of 5, no, it's not equal. So A is not equal to it, and it's done for us. And D is not equal to 7 to the power of 6. That's why we wrote it in not equal to 7 to the power of 6. Here, drawing around the number that the arrow points to, mister, it's between 5 and 6. Between 5 and 6, I got here 5.5. Okay, good, but let's do it in roots, because here they're providing only roots. So I got here, mister, square root of 25, and I got here square root of 36, right? Good. Do you think square root of 11 is between square root of 25 and square root of 36? No way. Square root of 22 is between square root of 25 and square root of 36? No way. Square root of 30 and 35, yes, both of them, mister, are in between square root of 25 and square root of 36. But one of them is closer to the half, the other is closer to the very end. Look at this. I will put square root of 35 here. Very close to 6, not before the half. Okay, so square root of 35, no way, mister. It is too close to being square root of 36. It would be very close to 6. But this one, yes, it is the only one that is left, square root of 30. Standard form, we agreed here. I'm going to move the decimal point until I make a number that is between 1 and 10, which is actually going to be 7. Multiplied by 10 to the power of, oh, you moved the mister 1, 2, 3, 4 digits to the left. So positive 4. 7 times 10 to the power of 4. An ordinary number. Mister, an ordinary number. What does this mean? Ordinary, we agreed it's the same as writing it in full. So answer it. So multiplying it by 10 to the power of negative 3, we agreed. Multiplying by positive power of 10 means you gotta move the decimal point to the right. Mister, it is negative, so move it to the left. How many digits? 3 digits. I have only one here, mister, so it is 7, 5. I need 2 more. So 0, 0, put the point. So it's 0.0075. Write each of these expressions in the correct column in the table. 1 has been done for you. So this is 4 cubed. Yes, equivalent to a natural number. It is equivalent to a natural number, and we agreed. What is a natural number? In the very first session that we took, a natural number is only positive numbers. positive numbers. So which of them has a positive value? This has a positive value. Yes, it's going to be it's going to be 64. This one, yes, yeah, so it's going to be 25. So I'm going to write over here also -5 squared. Now this, is it going to be positive? We agreed. The cube keeps the same sign. So it is -2 cubed. This, no, is the cubic root also keeps the same sign. If it is negative, remains negative. If it is positive, remains positive. So it is going to remain the same cubic root of -8. The answer of it will be negative. So it is not a natural number because we agreed natural numbers are only positive numbers. Draw a ring around the statement that is true. Square root of 7 is between 3 and 4. Let's see. 3 is actually square root of 9. 4 is square root of 16. Definitely no. It's not between 9 and 16. Root of 9 and root of 16. Here is square root of 16, square root of 25. Oh, yes. This is the one that is true, Mister. Okay. And if you continue here, this is 25. And here is root of 36. No, square root of 36 is not between root of 25 and root of 36. They are equal here. And here is going to be 36. And here is going to be 49. So no, Mister, this is not between root of 36 and root of 49. Is bigger than both of them. Okay? So it's just the second one is the only right answer. And this is the statement, not statements. Write this in the standard form, the same thing. I need a number that is between 1 and 10, so it's just 7. Times 10 to the power of, we need to move the decimal point, 3 digits to the left, 6 digits to the left. So it is 10 to the power of positive 6. Here, they've given us 3 standard form numbers. Look at this, between 1 and 10, between 1 and 10, between 1 and 10, and all of them multiplied by a power of 10. Good, no problem at all. So let's remember what we agreed on in lesson 1.2. You need to arrange the numbers from least to greatest. So how are we going to do this? Look at the indices. The smallest index is which one? I have a 4. I have -1. I have -1. Mr. -1 is the smallest, but I have 2 -1s. Look at the numbers that are here. What are the numbers that are here? 6.4 and 5.5. Which one is the smallest? 5.5. So this is the smallest one. 5.5 times 10 to the power of -1 comes after it. 6.4 times 10 to the power of -1. The highest and the largest is 5.5 multiplied by 10 to the power of 4. This one here, 200 to the power of -3, is the same as 1 over 200 to the power of W. Mister, we agreed. If we flip it, the negative becomes positive. So W is 3. Write this in the standard form. Mister is going to be 6.2 times, move the decimal point 1, 2, 3, 4 digits to the left. So it's 10 to the power of positive 4. 6.2 times 10 to the power of 4. Write 8.1 times 10 to the power of -3 in ordinary. No problem, Mister. It is multiplication by this. So I'm going to make it division by 1,000. Or I'm going to move the decimal point 3 digits to the left, not 3 digits to the right. So it's going to become 0.0081. Moving the decimal point 1 digit here. No, I need 2 more digits, Mister. So 2 more zeros, 0.0081. Here in this question, x is an integer. All right, what is it going to be? Complete these sentences about x. One possible value of x is, well, Mister, here definitely this is a third. So I need 1 is cubic root of 1, and 2 is cubic root of 8. So it is between it's any value between cubic root of 1 and cubic root of 8. It could be cubic root of 2, or cubic root of 3, or cubic root of 4, cubic root of 5, cubic root of 6, and the last one is cubic root of 7, right? So one possible value for x of x is what? Any of these? No, Mister, but don't forget not to write the cubic root. Why, Mister? Because they want x itself, the one that is under the cubic root. So it could be any of these. It's either 2, 3, 4, 5, 6, 7. Any of them would be correct for x. Cubic root of any of them. Good? So how many values are there that is possible? There is a total of 1, 2, 3, 4, 5, 6 values. 6 possible values. 1 over 5 to the power of 3 is the same as 5 to the power of, we agreed, if we flip it, we change the sign. If it's positive, it becomes negative. If it's negative, it becomes positive. So it's 5 to the power of negative 3. Here is 6 to the power of 2. 5 plus negative 3 means 5 minus 3, which is just 2. 6 to the power of 2. Less than 8 to the power of 6. So 8 times 8 to the power of 2 is 8 to the power of 4. 8 to the power of 5. Here is going to be 8 to the power of 10. Here is going to be, it's just 8 to the power of 0 written for us. Here is going to be 8 to the power of 1 plus 5 is 6 plus 1 is 7. Here is going to be 8 to the power of 6. But which one, yeah, mister, is, which ones actually are less than 8 to the power of 6? Less to the, than 8 to the power of 6. I got A, it's done for me, mister. All right, B is less than 8 to the power of 6. Yes, so I got here B. I got here C, which is 8 to the power of 10 is supposed to be written here. C. This is 8 to the power of 0 is equal to 1. 8 to the power of 0, which is D, and it's the only one that is equal to 1. E, 8 to the power of 7, it is greater, E. And here is 8 to the power of 6. So where am I supposed to write it, mister? Is it greater than 8 to the power of 6? No, it's 8 to the power of 6 exactly. Less than 8 to the power of 6? Come on, mister. It's less than 8 to the power of 6, but this is 8 to the power of 6 exactly. Good. So what am I supposed to write it outside the both circles? So you're going to write F anywhere outside both circles. Look at the numbers in the box. Draw a ring around all the irrational numbers. This is irrational? Yes. All right, is this irrational? Come on, it's a fraction. Rational means any number that can be written as a fraction. Irrational? No, mister. Terminating decimal is rational. Cubic root of 8? No, mister, that's an integer, it's 2. Square root of 8? Yes, square root of 8, I cannot find an answer to it. It's a third. 1.5, repeating 5 is irrational? No, mister. Recurring decimals are rational. They want only irrational. The population of Italy is about this, right? The population is standard form. I'm going to move the decimal point until it becomes 6 times. I'm going to move it 3 digits, 6 digits, 7 digits. So it is 10 to the power of 7. I moved it to the left, so it's positive 7. The mass is here. Write this mass in a standard form. I'm going to move it 1, 2, 3 until it becomes a 3.2 times 10 to the power of negative 3. I moved it 3 digits to the right. This one here, how can I know I misheard the whole number? Well, square root of 71 is what? It's between what and what? It's between square root of 64, which is 8, right? And square root of what? Huh? What's the one that is after it? 81. The perfect root that is after it, which is 9. Yeah, now, mister, definitely square root of 71 is somewhere in between. Well, what are all the numbers that are there in between 8 and 9? ايه هي numbers that are between 8 and 9? You're going to find 8.1, mister, or 8.2, 8.3, until I reach 8.9, and it could be 8.132 or 8.525. It's anything, mister, that is between 8 and 9. If you noticed in all the possible answers that I got there, between 8 and 9, then definitely it's 8 point something. Definitely 8 point something. So it is a Mr. 8. They're asking about the units place, the whole number. It is 8 point something, definitely a Mr. because it's between 8 and 9. A scientist writes this, and they want it in the standard form, and they draw a ring around the correct answer. In the standard form, I moved it 3, 6, 7, 8. So it is a Mr. 7.6 times 10 to the power of, moved it to the left, so to the power of 8. Which one is it? Is this one. The scientist measures the width of the a human hair as this. Right in the center form, the same thing. But I'm going to move it to the right. 3 digits, 4, 5 digits. So it's 4.6 multiplied by 10 to the power of negative 5. I moved it to the right. So here is the answer, 4.6 times 10 to the power of negative 5. Tick to show which of these expressions is the number written in the standard form. No problem at all. Let's do it. I need to move it 3, 6, 7. So it is 8.7 times 10 to the power of positive 7. Positive 7. Why? Because I moved it 7 digits to the left, so it's positive 7. 8.7 times 10 to the power of 7 is this one. All right, 45 here. It says to you, find the value of w, x, and y. Good. All right, here, 2 to the power of 3, all to the power of 2. Let's just say that this is question 1, 2, and 3, okay? So let's do 1. Now we're going to do 1. They're saying to you 2 to the power of 3, all to the power of 2, which is 2 to the power of 6, divided by 2 to the power of negative 2. So divided by 2 to the power of negative 2. Bases are the same, so 6 minus 2. It's 2 to the power of 6 minus negative 2, which is 2 to the power of 6 plus 2, which is 6 plus 2, which means 2 to the power of 8. So W, Mr. W equals 8. All right, here, 4 to the power of negative 2. 4, that's question 2. 4 to the power of negative 2 times 4 times 4 to the power of x equals 4 to the power of 12. How can I do this? They're saying it to you here as if they're saying negative 2 plus 1. What is negative 2 plus 1? Negative 1. So they're saying to you negative 1 plus x equals 12. What is the number that I add to negative 1 to give me 12? Yes, it is 13, positive 13. So x is 13. Or if you want to use algebra, no problem. Move the negative 1 there with the opposite sign. So it's going to become x equals 12 plus 1, which is also 13. So you can do it mentally. And by the way, even if you switch the terms, if you write here this semester, I'm going to write it as x minus 1, and instead of minus 1 plus x, keeping the signs the same, كده الساين بتاعت x is positive, الساين بتاعت 1 is negative. I kept the sign of the x positive, the sign of the 1 negative. X minus 1 equals 12. What's the number that you write here? 13. برضه يا مستر minus 1 is 12. So you got 3 different ways. Do whatever you like. Okay, next. The third, 6 to the power of y times 6 to the power of y equals 6 to the power of negative 16. What is the number that you add to itself and gives you negative 16? Yes, it is negative 8, negative 8. If you do negative 8 plus 8 plus negative 8, I mean, that will give you, same signs, add negative 16. So y is negative 8. Okay? Here, it says to you, write, here are some calculations. Write each calculation in the correct column. Answer is positive, answer is negative. Negative times positive, negative, mister. So negative 63. We agreed same signs is going to be positive. Different signs is going to be negative. So here is positive, here is negative. All right, so here is negative 63. Answer is positive. Sorry, they just need us to write the calculation, all of it. So what I'm going to write here, this answer is negative, so you're going to write it here, negative 9 times 7. It's done for us. This sign, negative divided by negative, we agreed. Same signs, positive. So definitely this is going to go here, negative 8 divided by negative 4. Negative 3 squared, it means negative 3 times negative 3. Mister, squaring any number in the world would be definitely positive. So it is negative 3 squared. Here, 12 divided by negative 3, positive divided by negative, the answer is definitely negative. So it is going to be 12 divided by negative 3 written here. Okay, this is going to be negative. Draw a ring around to the number that is rational. Square root of 2, that's a third, Mister. But square root of 4, it's an integer, it's rational. Square root of 6, I can't. Square root of 8, I can't. And this is around that number, it's only 1. Write this as in the standard form, 50,000, move it 1, 2, 3, 4. Mister is going to be 5 times 10 to the power of negative 4. And here as an ordinary number, which means write it in full. So Mister, I'm gonna, in multiplication, what we do is that in multiplication, we agreed here it was 1, 2, 3, 4. Sorry, I made a mistake also here. It's positive 4. It is 5 times because I moved it to the left. So moving it to the left is actually 5 times 10 to the power of 4. Where I agreed left, it means positive sign. All right, good. Here, 4.07 multiplied by 10 to the power of negative 3. It means here that I need to move the decimal point to the left 3 digits. So it's going to be 0.00407. Now I moved it 1 digit, but I need 2 more. So I put 2 more zeros, then I put the decimal point. So 70400.0. 6 to the power of 5 times 6 to the power of negative 1 is going to become what? 5 plus negative 1 is going to become 4. 4 minus negative 2. This is 4 minus negative 2, which means 4 plus 2, which is actually 8 to the power of 6. Here, this is 1 over 81, which means 1 to the over 9 to the power of 2 equals 9 to the power of what? We agreed if we flip it, it's going to become negative 2. So 9 to the power of negative 2. This one here, they take to show if the statement is true. Square root of 36 is 6. So 6 times 3, we do the multiplication first. 3 times 6 is 18. 2 plus 18 is 30? No, Mr. False. 2 plus 18 is 20, not 30. We do the multiplication first. Some of you might have done it true. Why? Because they did 2 plus 3 first. They said it's 5, 5 multiplied by 6. So they did the order of operations wrong. So it is 2 plus 3 times 6, which is 18. 2 plus 18 is 20, not 30. But the next one here, I need to do the multiplication first. So it's cubic root of 8 times 3, which is 24, plus 3, which is going to be cubic root of 27, which is equal to 3. So it's also false, not true. 24 plus 3 is 27. Cubic root of it is 3. So it's false. Here are some numbers written in standard form. Write down the largest and the smallest of these numbers. The largest one is the one with the highest power, which is this one. So 3.2 times 10 to the power of 6. The smallest is the one with the smallest power, which is this one. 5.0 multiplied by 10 to the power of negative 8. Next, find the 2 pairs of values of P and Q to make the equation correct. So let's do this. So I want P plus Q gives me 2. What are the 2 numbers that if you add them up, they give you 2? And they said 2 pairs of values. Mister, I could have written, maybe, I could have written 4 and negative 2, right? Isn't 4 plus negative 2 going to give me 2? Yes. Someone else might say, Mister, I'm going to write 3 and negative 1. 3 and negative 1, both of them are what? If you add them up, they're going to give me 2? Yes. Okay, good. So there are many actually possible answers. The most important thing is that when you add them up, they give you a 2. So someone might say also 5, Mister, and negative 3. If you add them up, they're going to give you 2. Yes, this is also possible. Okay, let's continue. Draw a ring around each of the two irrational numbers. So there are 2 irrational numbers here. 3.4 terminating. I'm sorry, we can't. Square root of 5. Yes, that's a third. Square root of 16. No, I'm sorry, it's a 4, and definitely pi. Is this statement true? The square root of 64. Square root of 64, mister, is 8. Is 8 or negative 8? Yes, يا مستر صح. It's positive or negative 8. Why? لأن if I say 8 squared, it is 64. Negative 8 squared, it's also 64. So the square root of any number is definitely positive or negative, that answer. Good. But negative 3 squared, is it equal to negative 9? No way, mister. Negative 3 squared means negative 3 times negative 3, which is positive 9. So it is false. Complete the equations by writing an integer power in each. Let's do this. Here, 7 to the power of negative 2 divided by 7. Well, negative 2 plus what gives you negative 6? Mister, negative 2 plus what gives me negative 6? Negative 4. So this is a negative 4. 2 times what? Because we agreed if I have one base to to a power, then to another power will be multiplied, okay? So here, 9 to the power of 1 divided by 9 to the power of 7 is equal to 9 to the power of 1 minus 7. We agreed in division, we subtract the powers, so equal to 9 to the power of negative 6 semester. So here, 9, so we agreed this is 9 to the power of negative 6. 9 to the power of 2 to the power of what is equal to 9 to the power of negative 6. 2 times what is the same as negative 6? 2 times negative 3 semester will give me the same answer as this, which is 9 to the power of negative 6. Next question. It says to you here, draw a ring around the two numbers that are exactly divisible by 9. We agreed in the very beginning of the video, if we add the digits up, they must be a multiple of 9. 3 plus 9 is 12. They are not a multiple of 9 because 12, I have 9, I have 18, but I don't have 12 in table 9. 5 and 4, add them up, they give me a 9. Yes, thank you. 9 and 6, 15. It's not in table 9. 1 plus 2 plus 3, 6. Not in table 9. 2 and 9 is 11. 11 and 7, 18. It's in table 9, Mr. 18. Yes, thank you. 4 and 1 is 5. 5 and 8 is 13. It is not in table 9, Mr. Thank you so much, everyone, and see you in another video.